Hello again and welcome to the ZGuy programming channel, Python edition. Today's topic, string formatting. In this tutorial we're going to discuss some additional options for formatting information displayed with the print command. So let's get started. What I've done is I've predefined 5 variables, name, age 45, balance, and new balance. The first variable is a string. The second variable is still a string because it's enclosed in quotes, even though it's a number inside the quotes. Then we have the variable age 45, which will have an integer value. Balance and new balance both contain floating point numbers. Okay, let's take a look at our first two formatting options. The first one is %s, and that is used when you want to display a string. %d is used when you would like to display an integer value. And here is our string, Bob, and our integer value, 35. So let's go ahead and run this program. Let's save it as formats.py. And when we run the program, we get my name is Bob, and I am 35 years old. So it substituted these two parameters in the order that you see the parameters here. It works left to right and substitutes them into these string formatters that have the % sign in front of them. Now let's make one little change here, and instead of using what we call hard-coded strings and numbers, let's use the variables that we have already defined up above. Alright, we'll run that program after we go through the next phase here, just to save time. The next thing we're going to look at is a little modification that allows us to display a decimal number using a little more space, or we can predefine how many characters of space we're going to use when we display the decimal number. And by putting a number, in this case 3, between the % and the D, we're able to force the output to take up 3 characters worth of space when it prints that integer number. So let's see what that looks like. Let's save this, run the program again. Uh-oh, what did we do here? %D format, a number is required, not a string. Okay, my bad. This is what a Python error looks like. It will tell you where in your line 13, that you made your mistake. It'll print that line to the screen to show you what it looks like, and it'll give you a description of the problem. It's saying we have a %D format. A number is required, not a string. The age parameter is a string, even though there's a number in it. So it detects that when your program is run, and it realizes that there's a mismatch with the type of variable that you're putting in here. So we can do a couple of things. Let's do what we did in our first program. We'll convert this to an int. And display it that way. Let's try that again. Alright, so this time it works. It substituted the variable name, which contents were Bob, and the variable age, which had 35 in it, and it substituted them as we would have expected them to. And here's where we use that format identifier of %3D. When it displayed the decimal value, the integer, it gave us 3 spaces of information. Okay, just another option you have in order to help space things properly on the screen depending on how you're trying to display your information. Alright, the next thing we're going to look at is how to display a floating point number. So we use a %F as our placeholder. We got it in two places, and we're using two floating point variables. Let's save that and run this version of the program. And now you see your floating point numbers have displayed. Probably not in the format we would like to see them because it has so many positions behind the decimal point. But don't worry about it, we can fix that. If we go up here between the % and the F, we can tell it how many decimals we want displayed. So in this case, we'll do 0.3, and over here we'll do 0.2, just so you get an example of what they both look like. Save it, run it, and the 0.3 gives us 3 decimals, and the 0.2, as expected, gave us 2 decimals. All right, next we are going to look at 2 more formatting operators. That would be %O and %X. And this is for displaying an octal or base 8 number, and this will display a hexadecimal or base 16 number. The parameters that you use will always be decimal or base 10 numbers. So as you can see, we pass the same number, 35, 35, 35, into each one of these. Let's run it, and we'll see how it displays those numbers. All right, so our base 10 number, which is the counting system we use, is 35. In base 8, the equivalent to 35 is 43, and in base 16, the equivalent to 35 is 23. So it's a good handy tool when you're programming. Quite often you may find yourselves working with a hexadecimal number, not so much octal, but occasionally you'll see hexadecimal requirements, and this gives you the ability to do that conversion for you. All right, the next type of formatting we're going to look into is what is referred to as escape codes. We have 3 that we're going to review today. The first one is a \T, which is a tab, and that will cause the cursor, after it displays information, when it gets to the \T, it will jump to the next tab stop. Every 8 spaces on the screen is a tab stop, so it will jump to the nearest tab stop from where it last displayed a character on the screen. The \R is a carriage return. That will cause a cursor to go back to the beginning of the line that you are currently displaying information on. And a \N is a new line, and that one will cause the cursor to drop to the beginning of the next line on the screen. So let's save this and run it. So here we have the version where we use tab stops. It printed out decimal and it jumped to the beginning of the next tab stop. It printed octal and jumped to the beginning of the next tab stop. This is a handy feature when you're trying to organize columns of information. And if you want to create bigger gaps, you can use 2 of those \T's, one after each other, and you'll get a jump of 2 tab stops. This is the line that used the carriage return. So it printed the word decimal, and here's the AL that's left from decimal, and then it brought the cursor back to the beginning of the line, printed octal, and here's the AL that's left over from what you can see of octal, and went back to the beginning of the line and printed hex. Every time it goes back to the beginning of the line, as you can see, it doesn't print the word octal and then erase to the end of the line. It just prints as many characters as it needs, and if there's other stuff on the line, it gets left behind. And then finally, these last 3 were used with the new line, the \N, prints, goes to the beginning of the next line, prints the text, goes to the beginning of the next line, and prints the text. The next feature that we're going to go over are what's called special operators. And we have 2 of them that we're going to look at. The first is the plus or concatenation operator. We've created 3 variables and assigned them each a string, I, love, Python. Then we've taken and created a new variable D and assigned it A plus B plus C. So it's going to take those strings and bring them all together and assign them to D. So let's save this and see how that looks. Maybe not what you expected, maybe it was, but there you go. Every string is concatenated, but there's no spacing. How do we deal with getting spacing in there? Two ways that you can do that. You could set B equal to love space and take care of it there. And you could say D equals A plus quote space, there's your other space, plus B plus C. Alright, let's save this and rerun it and see what the difference is. There you go. Now you've got spaces between each of the words. You can either include them into your variable definition or add them between the pluses in order to create that space for you. Whatever is more convenient for you. There is no right or wrong there. Okay, the second special operator we're going to look at is the asterisk. And this is also known as the multiplication symbol on a keyboard. And that's what you should think of it as. It's a repetition character. We're going to set A equal to a dash. And then we're going to say D equals A times 20. Or replicate A 20 times. Let's go ahead and see what that looks like. Look at that. 20 dashes. Sure beats having to type 20 dashes on the screen and hope that you get all 20 dashes counted out correctly. A very simple way to replicate a set of characters. The next feature we're going to look at is called the slice operator. This allows you to extract from the middle or portion of the beginning or a portion of the end of a string a set of characters. This first example here, we are going to create string 2 and we're going to just grab one piece, one character from string 1. And the number 4 doesn't exactly match up to the fourth character, and here's why. When you look at this string of characters here, the first character is not referenced as position 1, rather it's position 0. So the fourth position would actually be 0, 1, 2, 3, 4. It would be character E. It's actually the fifth position from the front of the line, but it's referenced from 0, so that's why it's listed as number 4 there. We'll grab the letter E. And we'll print that string out. String 3 is going to grab more than one character. Starting at position 3, 0, 1, 2, 3. So it's going to start with the letter D, and it's going to continue up to, but not including, position 5. So it's going to grab positions 3 and 4. Key thing to remember is it's up to, but not including the fifth position. Alright, so let's run that and see what that looks like. Alright, so like we expected, we got the E from the fifth position, but the fourth number counting it from 0. And we got the D and the E when we said we wanted to go from 3 up to, but not including 5. Alright, so I'm going to put on the screen here a list of all the codes that we've gone over, just so you can have them all in one place for a quick review. Brings us to the end of the formatting, string formatting tutorial. I hope this has been useful to you and you've been enjoying this. The next video will be discussing variables in a little bit more depth.